Thank you, Megha. Welcome everybody. I think as always, if you have any question, please put on the chat box as early as possible during the session. Don't wait for the last minute because if it comes at the later part, we may not be able to take the questions. But if it comes during the discussion, we may be able to take either when we're discussing or as a special Q&A session. With that, let me start. We have taken this topic of AI and robotics in manufacturing. Manufacturing made in India is something which our government has been touting for a long time. Manufacturing itself is something which is undergoing revolution, and robotics has been playing role in manufacturing since 1960. In fact, robots are not new to manufacturing. Manufacturing had robots, especially where it was dangerous, hazardous situation. They use robots when it was, repetitive tasks. They use robots. And when I say robots, I don't mean robots which look and feel like human, but industrial robots. However, with the AI coming in, AI-enabled robots have become a game changer for manufacturing industry. And in today's session, we will actually look at both AI and AI-enabled robots and try to see, what role they are playing in manufacturing and how it is likely to change and how it's going to impact the manufacturing. Uh, you know, Also it will have a major geopolitical impact, right? Post COVID, there are a lot of questions on supply chain. There are questions on, and there is a focus on having manufacturing moved out of China, so that you are not putting all eggs in one basket. There have been a lot of things like Japan has been asking companies to move out of China and come to Japan. US has been talking about moving out of China and going back to the US. There have been several situations where neighboring countries of China like Vietnam and Indonesia have been taking benefits of companies wanting to kind of expand and move out of China. India, there is a lot of talk, can India benefit because companies are going to move out of China? But I don't think we have given a thought that if those countries, if they want to really compete with China on manufacturing, what will it take? And there have been several studies made, including by McKinsey and others, in terms of what is the how many robots does each country employ. Today, the largest number of industrial robots are in China. Um, you know, they are 100 times, not more, I would say about 15, 20 times more than what India employs. They are 3 times more than what US employs. So it's going to be, if countries are looking at competing with China and manufacturing, they will need to start looking at efficiencies created by robots. How can you make things more efficient? How can AI-based robots create a lot more efficiencies? And how does it cut cost? So that becomes an important factor. And if China has been heavily investing in intelligent robots and to some extent subsidizing it, it's going to be even more difficult for other countries to compete. So this is something which we need to keep in mind in trying to, which tells that why this topic is very important and very critical if you want to really look at made in India or if you really want to become a manufacturing hub. Also, the other thing we need to just keep in mind that there has been a counter question always, right? Which says that having more robots means job loss, right? And you put workers out of work, and then they will suffer. And what will happen in that situation? So that is the other area which we will possibly pick it up if we get a chance. But always we look at from perspective of job loss. Is not that you workers are losing job. Whenever new technologies have come in, there is a historical fact and something which has been which has been proved over time from industrial age, when the industrial age started, that whenever new technology is brought in, there is not a job loss, but there is a job change, in sense that certain jobs which are lost because those became irrelevant because of the technology, but a lot more new jobs were added because somebody had to learn about the technology and implement it. I think using the robots also has same situation, because while some factory workers may lose jobs on what they were doing, but with reskilling they can actually get a lot more better paying jobs and can do much more efficient work. So that's the bottom line, but we'll try to also look at the job impact if we can, during the session. With this, I know Kapil Raval has been with Microsoft for a very long time. He has been our cCep earlier. He has so much experience in AI, and Microsoft is doing a lot of things. And I would like to invite him to really share his thoughts on how AI and robotics are changing the whole manufacturing landscape and what Microsoft is doing there. Kapil bhai, over to you.
Thanks, Vaibhav, for your kind introduction. Hello, everybody. It's great to be with you all to talk about robotics and AI in the manufacturing industry. By way of introduction, let me tell you, I'm part of Microsoft Business Development team. My focus area has been AI platforms in different industries. So I look at industry trends over the next 18 to 36 months. I look at Microsoft engineering products and platform plans. I look at different use cases that drive investment from customers in different industries, and look at key players in the market driving those use cases, disruptors, unicorns who bring new innovations. And I also look at investment opportunities, including M&A. And all this from AI perspective. So we can, Microsoft can have an ecosystem of partners and SIs, as well as features and functionalities to take advantage of Microsoft market opportunities. Today, what we want to do is I'll start with a little bit about robotics and then go into AI. And then we'll focus on some of the use cases that we see are driven by AI and becoming more popular and contributing to the bottom line in this very cost-conscious industry. So let me share a couple of slides here. I hope you can see what I'm sharing. So in every country, manufacturing industry usually represents an important piece of the overall economy. Now, even in the US, and as Vaibhav mentioned, we all talk about or we complain about outsourcing of manufacturing. Even in the US, this industry still represents about 12% of the GDP. More than 3 decades ago, I worked as a service engineer for robotics and CNC machines at Aligunjan Engineering Company in India, where CNC machines were used to achieve automation and precision required in manufacturing gears, industrial gears. And robots were used for smooth welding of joints and precision cutting of iron plates. So obviously, this resulted in increased production capacity, improved product quality, reduced manpower, as Vaibhav said, also improved reliability and repeatability. It also reduced waste. It increased speed and throughput rate. So obviously, this automation reduced human resources required on the shop floor, but the IT team grew to plan, design, implement, and support these CNC machines and robots. Now, traditional robots automate tasks, as Weber said. They are good at doing the same thing again and again with the same level of precision. They are not designed to learn from their surroundings, or they cannot handle any unexpected events. So this market is now accelerating, as you can see in this slide, with the adoption of artificial intelligence. So AI makes these automated robots autonomous. Roomba, if you have used it, it's a good example, fairly simple example of a household robot with built-in AI. Now, the latest models of Roomba can learn from their experiences. They understand the layout of your floor and their experience. When they experience an obstacle, they understand that here, there's furniture. And over a period of time, they can actually create a complete map of your floor, including where you put the furniture. So similarly, In aerospace, in military, in mining, in healthcare industries, we are seeing this investment going into robotics. And I'm sure some of you have seen, not live, but maybe on TV, bomb squads using robots. So as Weber said, robots really deliver greater value in any task which is dull, dirty, difficult, dangerous, repetitive, or requiring precision. Now, according to McKinsey Institute, the impact of autonomous systems or robotics to global economy, and I'm talking about all verticals, all industries, would be about 6 trillion by 2025. Now, overall, if you see, not just manufacturing vertical, but overall the use of robotics and autonomous systems, then US and Japan are leading. Obviously, as Vaibhav said, in manufacturing space, China is leading in that particular area. Now, based on current estimates by several analysts, the market for overall robotics and autonomous systems is expected to be about 70 billion as shown in this slide by 2023. A couple of years ago, I wrote an article on robotics and autonomous systems and shared it on LinkedIn, where you can find more information in terms of the components of robotic systems and challenges of interoperability of robots. But here we don't need to go into that level of details. So in the near term, what we see in manufacturing industries, we are seeing growth in autonomous systems with shared control. So we have human in the loop. We call them collaborative robots or cobots. Uh, we also see the market for mini mobile robots is growing faster. Now, autonomous mobile robots are used to move materials, and I'm sure you all have seen this in movies or in some YouTube videos, that modern warehouses like Amazon, DHL, FedEx, UPS, they all have installed mobile robotic systems to efficiently move materials from their stocking shelves to the order fulfillment zones. So mobile robots are also found in, as I mentioned, in industrial, in military, even in security settings. And there are many players in the robotics market, and you'll find some of the examples on the slide, on this slide. So the manufacturing industry has really gone through several transformations, and I have been investing in technology for several decades to automate tasks and processes with one single goal of bringing down costs. This industry has invested a lot in automation to improve productivity. The processes have been optimized to improve efficiency. With Industry 4.0, we have seen connected machines that can now communicate. While the industry has invested heavily in automation, the switch to autonomous is slower. As I mentioned earlier, the industry is extremely competitive and as a result, very cost conscious, and rightly so. So we need a stronger business case and quick ROI for them to move from automation to autonomous. And the amount of investment required for moving to autonomous or coming up with lights out manufacturing versus benefit is something where we end up spending a lot of time for different use cases with different customers. The manufacturing industry has been a bit slower in adopting AI, although they have connected all the machines, but they're slow in adopting AI, but it is changing. Now, AI market in manufacturing vertical was 1 billion in 2018, but it's growing very fast and it's expected to be 16 billion by 2025. And obviously, one of the reasons for this growth is IoT, which has accelerated digitization and that gives us sensor and other data to train AI models. So it's very clear to today's manufacturers that if you're stuck to the old way of doing business and you don't have capacity to digitalize your manufacturing processes, your costs are probably going to increase. Your products are going to be late to the market, and your ability to provide distinctive value add to your customers will also decline. So digital transformation helps them by leveraging their existing assets in which they've invested, and then applying advanced technologies like AI, as well as mixed reality and autonomous systems to transform manufacturing practices. Now, I use autonomous system word um, more generically to not just call, because robotics is also part of autonomous systems. So that is the term more popular in the technology industry. So let me share with you one more study by McKinsey Institute. Now, according to this study, manufacturing processes, you can see, can benefit the most from AI adoption. The third area most benefited by adoption is supply chain, as Vaibhav rightly mentioned that at the start. And it is also an important aspect of manufacturing. Now, manufacturing industry is also pretty broad. So you have automobile manufacturing, you've got semiconductor manufacturing, you've got process manufacturing, you have discrete manufacturing, et cetera, et cetera. But if we look at macro level, you will find that there are three main or three key priorities of any CEO in this industry. One is to empower their workforce, deliver new and innovative products, and as well as services, and optimize their operations. So now what I want to do is look at each of them and then drill down and see how AI and robotics use cases can help them achieve these three main goals. So first one is about workforce enhancement, or empowering your workforce. So why are they doing it? As Vaibhav mentioned, automation and autonomous systems will displace about 75 million jobs, and it will create 133 million new jobs that will require new skills by 2022. So they really have to transform their workforce and also improve their productivity. And that's why they are really focusing on this, what they call empower the workforce. And with the introduction of AI, you are able to achieve 25% improvement in your workforce productivity. This is all based on different analysis reports. Now, what you see on the right-hand side are some of the use cases that are becoming very popular in this industry. And one of them is skill enhancement. This is fairly simple technology like mixed reality you can use. And with that, you are able to train, excuse me, your employees, giving them hands-on experience in a virtual world. You can also provide remote support to your field workers with mixed reality. You can have your experts remotely looking at what your field engineer is looking at, and guiding them. So you don't need to need your experts to travel to different locations. The second one is task management and process automation. So you can now, with RPA tools, you can automate many of your back office processes. And this will definitely impact, or it is impacting the BPO industry in India. But that's a topic for some other day. And here, the players are like, as I mentioned, Blue Prism, UiPath, Automation Anywhere, and they have large market share in this particular area. And Parsable is a player that focuses on field workers, or you can call them deskless workers. And it actually automates some of the tasks that these field workers are performing. And it becomes easier for you to then, hire a new person and get that person productive fairly quickly. The third area is what we call defect and anomaly detection. Now, this is an important area in manufacturing, where AI can help improve the quality of products. So here again, what we use is Vision AI. With that, you can keep an eye on your product finish being manufactured, And as the tool wears out, you can warn your operator to change the tool before it starts deteriorating the quality of the product. So let's take another example and something you may be all familiar with. So manufacturers, check quality of just a sample of products from each batch because it's very time consuming for humans to check the quality of each and every product in every batch. But with AI, you can now check each and every product because there is no human limitation involved here. Um, Third area, I can give you an example, which is fashion industry. So fashion products or perfumes that you buy, you will find that the bottle or packaging is usually flawless. And these industries, these manufacturers really focus heavily on the bottle quality and packaging. And this is a very fast growing area for AI with anomaly detection. And these manufacturers do not want any flaws in their perfume bottles or packaging. And here again, we combine vision AI with cognitive analytics. Cobots, we call it collaborative robots, definitely helps you improve the productivity of your workers. And we already covered this topic at the start. Another area is health and safety of your workers. So CEOs don't want any accidents, any fatalities in their manufacturing plants. They want to avoid the accidents occurring in their manufacturing plants, any kind of injuries, any kind of fatalities. Um, and I think you're all familiar with video surveillance solution, generic. But with AI, we can now take this video surveillance to the next level. You want to ensure that no one goes in hazardous areas without helmet or other protective gear. Here, AI can go down to that level and stop access to anyone who does not meet that criteria, even if they have access cards. And I know there are about 25 different use cases within this category that are prevalent in manufacturing, energy, and mining industries to improve worker health and safety with AI. We'll not go into all those 25, but at least it gives you an idea that that's an area where AI is becoming very, very popular. Let's look at the next priority area, which is deliver new product and services. On an average, manufacturers see about 40% of their downtime attributed to unplanned outages. So if you just focus on that with AI, you really make a significant improvement to the bottom line. So with IoT, we are now able to put sensors to monitor different areas and come up with predictive maintenance solutions to reduce unplanned downtime. And on the right-hand side, I've listed some of the use cases. So we now see many leading manufacturers, delivering their products also as a service. They are not selling their products, but they sell that product as a service. So for example, Rolls-Royce sells their aircraft engines as a service. So with 5G, with IoT and other technologies, they are able to monitor their engines remotely and carry out preventive and predictive maintenance to improve service and reduce downtime. The customers also benefit with this. Manufacturers get recurring revenue. Now the use cases vary from remote maintenance with mixed reality, as we mentioned earlier, to using digital twins for proactive and predictive maintenance. A digital twin is basically a digital replica of physical equipment or physical world. Now, the idea is to take actual reading from your physical equipment, process it, and try out remedies in your digital world and see the results, and then implement them in the real world. So this eliminates trial and error on a physical equipment. Uh, I remember when I worked at Elecon, one of the most difficult tasks as a maintenance engineer was to recalibrate CNC machines. And now with AI, this is simplified. Um, the next area, if you see, is optimizing their operations. Now, basically, what we are talking about is making their supply chain more intelligent, and as Vaibhav mentioned at the start of it, and this improves the overall efficiency by about 4%. Now, I'm sure you all understand the difference between productivity improvement and efficiency improvement. Productivity improvement focuses on just the output, where the efficiency improvement focuses on end-to-end process, quality, cost, etc. So 4% improvement in efficiency improves your bottom line by more than 4% improvement in productivity. So it's a significant improvement. And with COVID-19, as Weber said, we see that there is increasing interest in using AI for supply chain risk management. This is an emerging area in supply chain. Besides just understanding demand and inventory, etc., the focus is on supply chain risk management. And this is not just limited to manufacturing, for example, transportation, logistics, pharmaceuticals, energy sector, food and beverages, all these sectors are now looking at supply chain risk management. And that is where AI is heavily used. Now, they're all now boosting, the growth of the supply chain risk management market. We've also seen several governments are now focused on adopting supply chain risk management solution to identify, assess, as well as prioritize risk to national critical functions. So companies desperately need a way to pinpoint their underperforming risky suppliers and take appropriate action in a timely manner. And the challenge is that while the supply chain performance management solutions are in the market today, can help collect data and score the supplier's functionality, they have limited capability to manage a more complete risk profile. In the current market conditions, and with the credit crunch and unpredictability, unpredictable commodity prices, everybody is now forced to be laser focused on supply chain risk management. These are some of the use cases, and I'll move to now. What are the future trends? Now, let's understand future trends by looking at where VCs are investing. Usually, that is where I go. As if the VCs are investing in particular area, then that's definitely expected to grow in the next 18 to 36 months. We see that they are investing more and more in areas like cobots, which we discuss, AI, additive manufacturing like 3D printing, and we also see a lot of simulation being used in design as well as in training robots and autonomous systems. So these are the areas where we see more and more investment going in the manufacturing industry. And the simulation tools is a great example that not only helps you on the design side, but if you want to train your robots, you really need simulation software for that. And since this is a webinar organized by a law firm, let me leave you all with a slide that shows results of a study done by Cognilytica in the US, showing current state of laws and regulations in different for different solution areas of AI. All that is blue is really Vaibhav and Mihir opportunity areas for laws and regulations. So with this parting thought, I hand it over to Vaibhav. Thank you.
Thank you, Kapil Bhai. I think what you said was mind blowing, right? In a sense that already so many places AI and robotics are being used in manufacturing industry. There are so many opportunities where it can improve and it can add value to a level where what I understood from you is that it can create a huge impact on the bottom line, or a significant impact on the bottom line. And if I really to summarize what you said in just one line, right? I would say that if we don't embrace AI and robotics in manufacturing, we will become uncompetitive. We won't be in business anymore. Um, so I think this is really eye-opening in that sense. Let me come to Mihir, and Kapil, I'll come back to you with questions later on. But let me come to you, Mihir. Mihir, Kapil has given us solid data points,
Yes.
examples, use cases on
Hmm.
where it is used. You know, how 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 people are using it, where VC is investing, and so on and so forth. So, he has given a very good overview. Can you pick up some of those areas and go a little deeper into that, or add a little bit more on where, how, AI and robotics do you think will affect the manufacturing industry?
Absolutely, Vaibhav. I think this was a fantastic presentation, Kapil. It's amazing you covered so many points. If I can't, I started taking notes, but I couldn't keep up with it. Talk about empowering workforce, talk about delivering new products, talk about efficient operations, and all those different use cases you gave was superb. However, what I would like to do is just, as you said, just go a little deeper into it, and perhaps even add a couple of additional points here and there. Uh, One of the biggest problem manufacturers have, apart from all other things, workforce efficiency and all that, is a demand forecasting. Now, Kapil Bhai had mentioned demand management. Let me go a little deeper into it. Demand forecasting is a very crazy thing. There's a concept called bullwhip effect. What happens that you are a manufacturer, you are not facing a consumer. Who are facing consumers are retailer. So if there is a sudden change in demand at the retailer end, when consumer wants something and there are more people wanting it, that demand gets amplified by every intermediary in the process, in the supply chain, right? Because every intermediary wants to keep certain percentage as a buffer so that they don't run out of product. So this bullwhip effect, what it does, it amplifies the demand by the time it gets to manufacturing. And usually you see that in consumer discretionary product where a lot of those products depend on the taste and the fashion and things like that. But they can also happen in consumer staple. I will give you an extreme example of toilet tissue in COVID situation, right? Suddenly everybody were running to get toilet tissue. Now, what happens? You run out, retailers run out of those. So they ask their wholesaler about providing more of those. Wholesaler then go back and to manufacture. So what manufacturer is suddenly dealing with this situation where they start creating excess production, right? Now, this, if it is a temporary, it can stall out like in a COVID situation sometime. But sometimes those decisions are made for long term. If you're looking for adding a new plant, looking for adding a new production line, hiring more people, those things are more, or getting more raw material, those things are more long term. So having this bullwhip effect leads to excess production, high inventory level, transportation bottlenecks, poor customer service, wrong capital investment decisions, and of course, short supply of other products because resources get moved from one product to other product. And suddenly that demand drops and you are left with all these issues. So that is very, very critical in manufacturing process. Now, AI can look at all kinds of data, and based on that, it can temper the effect of bullwhip effect to some extent, and that can be very helpful area in order to reduce cost, in order to reduce short supply, in order to ensure right delivery at the right points. Wherever there is a demand, you shift your excess capacity or excess inventory to those areas. So predicting that entire demand forecasting and predicting the usage pattern is very important, and AI can be a huge help there. Another area that Kapil touched on was additive manufacturing. I'll give you an example. Increasingly we talk about mass customization. People want their own way, yeah. And that means you have to create a flexible manufacturing system. And flexible manufacturing system requires you to adopt very fast. Suddenly change your production schedule, suddenly change your production line, your flow of material, allocation of people resources, all of those have to be changed. Kapil, I gave you example of that, retooling your CNC machine, right? It used to be very difficult in old days. And I remember because I am a mechanical engineer myself, and almost 30 years back when I was studying, I worked on a CNC machine that was very new in India at that time, and I was just happened to have access to that. So for my final year project, we worked on it. It took a lot of programming to retool the CNC machine at that point of time. And you can't easily change that because you have to reprogram, understand the entire flow and reprogram those tooling. Now with AI, it becomes easier and easier. But another advantage that I'll give you is with the additive manufacturing. Additive manufacturing also reduces significant scrap because currently our manufacturing processes are you take the entire material or the large chunk of material and you remove stuff from that, right? So whatever you remove, a lot of time gets reused, but a lot of that becomes scrap also. While editing, you are adding into the adding material as and when it needed. So it reduces scrap, but that requires again AI-based modeling. Another example of additive manufacturing I can give you is a co-manufacturing with customer. Think about, for example, you are buying this high quality earbud, right, for your all this video conferencing needs. So you need to have this earpiece which connects into this like this, right? Now the problem with this earpiece is that you get the earpiece with a silicon tip, right? Now think about it. I may produce a great earbud, but my silicon tip is not customized to the contours of the ear of the user. It's going to get dropped. And then what ends up happening, your product gets used less. How about doing this, where you produce a great earbud and you give the standard tips, silicon tips to the user, but you also give them opportunity to download a program for their own website to create a customized tip, which is based on the contours of the user. And now we have, very good mobile phones and all of those. We can take the picture and take the different dimensions of your ear and feed into the program. And if you have a 3D printer, you can create a silicon tip. Now, suddenly you have co-created with user and created real mass customization without changing your own big processes. So those kind of tools are going to also come into picture. Few other example, if I may give, factory layout planning. If you remember Kapil Bhai's first slide, it showed very interesting layout of a factory. Now, factory layout is not like a building a house. I want 2 bedroom and 3 bathroom and things like that, right? It's very, very complicated because you have to think about the movement of material. You have to think about the people workflow. You have to think about the energy usage, all of those. And also usage of the space. So you have to customize all of those things. You have to bring into the model and think about how am I going to lay out my factory. But at the same time, I want to make sure if there is a change in the process, how I can make it more flexible. So all of those things, predicting the bottleneck in the flow when you are moving the factory and material through the factory and the people through the processes. So that part is also very, very important where AI can play a huge role. Of course, there have been simulations, but combining simulation with AI can be very useful. Kapil Bhai talked about, product design and quality checks. One aspect that I want to mention here is also regulatory requirement for product check. So where AI and this robotics and the visioning AI that he mentioned can come in and help you with the regulatory compliance with the product quality for every unit of the product. It can also optimize the product design for material requirement. You don't use more material than what is really required in the product. In terms of design of a product, it also optimizes for manufacturing methods that you use. It can also optimize for the processing time and the processing schedule that you have, and also energy usage, as I mentioned earlier. Kapil Bhai mentioned a lot of areas on the factory operations where you're looking into prediction of machine and tooling usage in order to resource acquisition and resource allocation. Think about predicting the material requirements, also very important. optimizing multiple production shifts. That's where also AI can come and help. Another area that he had mentioned, and I want to add a little bit, is training workforce, empowering the workforce. Excellent use cases. There are a few things that I would also add to it is identifying the need of training for individual worker. Companies have this mass usage, programs of training. Everybody has to get trained on this. Yes, that's great. However, certain workers are good in certain things and certain things they need more training. So how do you identify individual needs of training? And how do you customize training program for those individuals, which is where also a lot of AI can come in. And that comes from my background of adaptive decision support system, that how do you adapt to individual user in making decision? In this case, how do you adapt to individual user in looking at their training needs? And another area is also reallocation of workers based on their skills. A lot of time workers get frustrated because they get put into a situation where they either don't like to be doing or they are not well trained to do it. Right now you can retrain them. However, if you know their skill set, you may be able to allocate them and their preferences and the profile, you may be allocate them into other areas where they can perform better and increase your productivity, as we talked about earlier. So a lot of these areas, plant maintenance, reducing breakdown, eliminating accidents, those are all very important. Managing your production assets. So AI has huge opportunity, and I touched on AI, not on robotics, because we talked a lot about robotics, but AI certainly is going to give you another edge, like robotics did in last several decades in manufacturing. So that's my take on it, Vaibhav.
Thank you, Mihir, and thank you, Kapil Bhai. Let me just spend few minutes picking up some points which you mentioned, Mihir, and some points Kapil Bhai mentioned, right? And go a little deeper, looking at the implications from India perspective, especially from legal perspective, right? And also, I think the last slide which Kapil Bhai shared was very interesting. There were a lot of blues, and the only area where there was some red was data privacy, right? So it kind of says that government has addressed the data privacy issue. That's something which has captured the kind of world attention, but there are a lot of other sides which government has still not looked at it, right? And there's a question from Ranjit also. His question is very similar. He says, uh, Mr. Kapil has shown the last slide in data privacy is shown in red and context of AI and robotics. Please briefly tell what are the issues involved. So let me address that question, right? So if you really look at it, what Kapil Bhai showed was what is the what are different areas in AI. So for example, he says facial recognition is a concept of AI, right? Now facial recognition, there is hardly anything which where you have seen any regulation has come in. Most of the blue means no regulation. Red means regulatory guidance is there. Green is there is permissive law, which means you are able to. You're given permission to do it. Red is okay. A different version of red is prohibitive laws, and yellow is where there is at least some thought process of discussing, right? That there is a thought process going. We need to actually have something, some regulation done. And blue means there is no discussion, no regulation, no permission, no prohibition. Everything is kind of a blue sky. So that is what it is. Data privacy is where there is some things, and it's not necessarily in AI. Data privacy is very important in AI, and the issues involved in data privacy is very simple. Any AI, you will need a lot of data. Any data, most of the data which AI uses is anonymized. If it's anonymized, it's outside the data privacy. Most of the data privacy regulations don't talk about anonymous data. They don't regulate anonymous data. They only focus on personally identifiable information, right? Both whether it's sensitive personally identified information or non-sensitive personally identified information. But there are a lot of data which is required, which are personally identifiable, especially if you want to do especially if you want to customize something, which Mihir talked about. right? So if you really look at, having a ear, right, contours, and then giving and creating the silicon tip which is based on the ear, you will end up giving your ear, your details. Similarly, you may end up giving your eye details if you want to have something on the glasses, specific glasses. Now, those kind of details which you give it to someone are your personally identified information which needs to be protected. That goes along with some of the other things, because those people will know what phone you use, what is your lifestyle. There are a lot of information which goes along with it, your digital profile, in other words. So those are the things which you want to protect, right? Now, when it comes to manufacturing, right, the personal information is less critical when it comes to consumer. I mean, it's more critical when it comes to consumer and social media. Is less critical when it comes to manufacturing, because in manufacturing you are not looking at what is individual lifestyle to create. I mean, you will be, but that will be a small portion. Most of the time you are looking at which product I'm going to sell. For that purpose, which is geography, which is the what is the category of people who will buy my product, and so on and so forth. So from prediction perspective, you will actually pick it up, but most of them will be anonymized data. AI will be used for anonymized data. So privacy data protection has implication, but less implication when it comes to manufacturing compared to, let's say, other areas like health or other things which we have discussed, consumer protection, retail. That's where it will be having a larger impact. But this is something which is at least considered. But there are a lot of other things. Take the first point of facial recognition. Most government has not done anything on facial recognition. Now, facial recognition has started to pick up an important factor. And recently, I don't know if people have seen it, IBM made a statement saying that they will stop offering facial recognition technology for general purpose use. Right? Now, those are corporate governance
Well,
themes, right?
Microsoft has also announced that. Amazon has
Yes,
also announced that. Just to add a little bit, yeah.
correct. In fact, I was coming to that.
Sorry.
I saw a lot of, no, you're right. So I know Microsoft, Amazon, and a lot of other, including Google and others, have started coming up with position papers, position saying that whether they will permit or not, right? And primary reason is, there is no law on it, right? So there is no restrictions, no permission, no prohibitions on how the technology is being used. And because there is no restriction or permission, it can be used for benefit, like in manufacturing, which we used for identifying obstacles, right, on a shop floor, so that the intelligent system can kind of identify that particular uh, uh, obstacle and move around it if it's a moving product, or if identify something is lying and alert a person so that that can be kept it if it is hazardous to workers, right? So there are multiple places where it is positively used, but same technology can be used in a very negative way, which government has used for surveillance and for various other things, right? So if you really look at um, uh, corporates, they are now looking this technology in absence of law, right, as their own responsibility from corporate governance perspective, and trying to inculcate the make it ethical, inculcate ethical part, and taking position saying that, look, if this technology, even though it is not regulated, if it is used for things which have negative implications on people, then I would want to make sure that I would kind of minimize the use, or prohibit the use, or license the use to only areas where it can be properly used, right? So in other words, the corporates have started doing job of government. So that is what the slides indicated, that there are a lot of technologies which are coming up, a lot of new developments which have happened, where there are no regulations. Data privacy is the only area where there is a little bit of red, which means that the countries have looked at the regulations. Most other places, regulations are missing, and corporates are actually taking up onuses on regulating it themselves to make sure that the misuse is minimized, right? The other area which I want to pick up is on jobs, and there has been a lot of discussion on jobs, and AI and robotics replacing humans. And as I was mentioning earlier, and as that it was mentioned by Kapil by and Mihir both, that replacement of job or reskilling is a reality. Any new technology, right from industrial age, right, any new technology which has come in has created a job replacement, right? It has kind of made the existing jobs redundant, and then people had to learn new skills to make it useful, right? Now the only difference in industrial age versus what it is today is the time frame for redundancy, right? In industrial age, if it took a generation before the job replacement came in, which means that most of that time before it became redundant, you had a generation time. One generation could do it, the other generation will then start learning new things, right? Or if even in that generation, as the time progressed, even that generation had to do once or twice in their lifetime, which means that if you learn a particular skill, you may have to learn one new skill in midlife or some other life, and that should be good enough for you to last you a lifetime. Uh, this is something what is called half-life of knowledge, and something which I actually learned from Mihir a few years ago, where the half-life of knowledge, the percentage of knowledge which becomes redundant from the time you learned it, right? The 50% of what you learned becomes redundant was 5 years, and it's coming down to 2.5 years. So basically, what is happening is that a lot of things you learn, you pick up, will soon become redundant. Now, same thing is happening in manufacturing unit. A lot of things you learn will become redundant, which means that reskilling and educating becomes a continuous process. It's no longer a process where I learn in school and then come back, and then if I need to pick up skill, I will go somewhere and then come back. It's a continuous processes, and exactly what corporates have to do now, what education institutes work is. And from legal perspective, we need to think how it is going to impact one, the negotiations with unions, right? Because there will be a job loss and there will be rescaling, right? How do you position with the union negotiations? Because most of these workers will have unions. And so that negotiations will become very critical, very important on what kind of skilling will you give to workers, how you will make sure that their jobs are protected or their livelihood is protected, even though job description change, who will bear the cost of that particular training, and so on and so forth. Now, also what's going to happen is it's not going to happen that the job change will happen in the same company, right? If it happens in the same company, you pick up the existing workers and train and put them in different role. Most of the time it will happen where it may happen in some other company which is actually technology savvy, and that result in job loss in some other company which is not technology savvy, right? So then that implication will need to be done. So from government perspective, government will need to change the labor laws to keep the implication of this in mind. Maybe make it mandatory for companies to train people or reskill people. Maybe just like how there's a CSR, there may be some provision where the companies need to put certain amount or certain profit or certain time for reskilling people, because this is going to become a reality. So how do you deal with workers? How do you reskill them? How do you give them livelihood, different kind of livelihood? How do you make sure that people whom you can't employ, but you need to kind of let them go? How do you skill them so that they have ability to survive once they leave the company? So all this government will need to start thinking and trying to change the labor laws to adopt the newer technology and the implication of newer technologies, right? So this is in my way some of the points which I think, at least from this aspects, which will affect from legal aspects and India aspects. Uh, I know we are 4 minutes away from the session, and I want to close on time. I know Kapil Bhai has to go. We have addressed already a few questions. There's a question from Manish Jain. His question is, I have programmed a chatbot in Python. Can you please tell me how can I execute the coding into robot for a screen attached to the robot, or a screen attached to robot? Manish, unfortunately, while I am an engineer, so is Mihir and so is Kapil Bhai. None of us may be able to answer your question because we have been all programmed in a very different way, and we have not programmed chatbot in Python. Unless Mihir or Kapil Bhai, you have anything, I will just move on this.
That's
One thing I would like to add, Weber, I think this is interesting question. And increasingly I have seen, especially from a lot of academic institutions and companies, where you don't really program robot by programming it, right? You oftentimes now they have adaptable robots where you do things and you move robot in a certain way and it learns from your movement and automatically does that. It gets programmed. So that kind of self-programming or visual programming, you can say in an old sense, right, is also coming into picture where you don't need to have high skilled IT people to program your robot. You do things, you teach the robot how to do it by moving it, and automatically that data gets fed into robot, and the robot will perpetually do that way. Now that also has a problem because robot can learn wrong things, uh, uh, and they may not be as efficient as we would like them to be.
Let me just add to what you just said, and I want to encourage who has developed that program
Manish.
in Python, Manish. So I think the next step I would request you to do is, get a Raspberry Pi and try to, use the Python program and use Vision AI with Raspberry Pi and train that your algorithm to see whether this is a Pepsi can versus a pen, and how it can differentiate between the two and what sort of success probability it gives you. When it comes to robotics, as Mihir said, and there are different ways different robots are programmed. There are also their own software that comes from the supplier, and that is one of the challenges we have today, because if you buy a robot from ABP, you buy a robot from Fanuc, how can they collaborate? How can they talk to each other? That requires something like having a robotics operating system, so that you can have this plug and play of different robots. But that's the future. Right now, robots and autonomous systems can also be trained by using simulators. So there are different ways you actually train them. There is reinforcement-based learning model where you reward them based on the action that they take. So first, I think you continue with Python, try to play with some Raspberry Pi and other things, and then gradually move towards robotics programming.
Thank you, Kapil bhai. I think we are out of time. I want Nishith bhai, he's there to give maybe one word or closing remarks. Do you have a minute, Nishith bhai, to speak?
Yes, of course, it's always wonderful to hear Kapil Bhai, and of course, with you moderating and Mihir's expertise, professorial or otherwise, uh, very educative. And I think as we move into the robotic area, I think all these questions are becoming very relevant. And I think it's good that we are thinking ahead of time on many of these questions. And I saw so much of blue space. So there's so much opportunity for blue sky thinking. And you can do a lot around that, especially when nobody governs you and you think of your responsibility. You create an environment, I think, which is much better than some external person coming and trying to regulate you. So I think this has been a wonderful discussion. I know time is up, but at the same time, just want to compliment and Kapil, we would love to have you a lot many more times on cCep. These
Anytime.
sessions have become very interesting and exciting, and as you can see from questions as well as the audience, uh, really wonderful. Thank you so much for finding time to be with us.
Thank you.
Appreciate it. Thank
For the
you.
opportunity.